Good afternoon, colleagues. I welcome all the recipients of the ICon-MaSTEd conference, and today's section decided to computer science education. The reports to be presented today are fully in line with current trends. In recent years, artificial intelligence tools have become widely used. Several presentations will be devoted to the application of artificial intelligence tools in education. Another trend is game development as a method of teaching programming. Also, today's presentation do not ignore the fundamental issues of training IT specialists. I sincerely hope that all participants are safe and that no incidents will spoil our communication. Let's get started, and I invite first presenter Natalia Shumeiko or another. Oh, Natalia. Please, I invite to presentation the study AI tools and their application for developing soft skills of computer science students. Please, Natalia.
Good afternoon. Good afternoon, ladies and gentlemen. Thank you for joining this session. My name is Natalia, and together with my co-authors, I'm honored to present our research titled AI Tools and the Application for Developing Soft Skills for Computer Science Students, the Perspectives of IT Specialists and University Teachers. So I just want to ask about the presentation. Is it possible to show it because I think that I can't upload it. I'm trying, but it's probably my co-authors can help me. Can you please? I kindly ask you if it's possible.
Natalia, try now.
Try it. Okay. So I will try it again. I don't know why, but you can see only just 1 minute.
Alona, can please, Natalia?
Yeah, please, Alon, can you help me, please? Thank you. Thank you very, very much. So, dear colleagues, you can see the title of the presentation. So let me proceed. The technical skills on the second slide, please. The technical skills of those who work in information technology are fundamental. However, as scientists stated in the past decades, soft skills have been more frequently required than hard skills. In the World Economic Forum's Future of the Job 2023 report, cognitive skills topped the list of those skills that were considered the most important skills to workers in 2023. The next slide, please. Creative and analytical skills rank first in the list of skills, the importance of which is projected to increase for employees by 72% during the next 5 years. So employees in the IT sphere also need not only technical knowledge from workers who work for them, but also professional skills that would allow the firms to achieve more and better results. And the next slide, you can see that AI is at the forefront of technology research and education. In this regard, the following question logically arose: why not use AI technologies, particularly AI tools, to work on the development of soft skills of today's computer science students? In the next slide, you can see the aims of research questions. What AI tools are available today and applicable to decide work tasks in the IT sphere and require strong soft skills to resolve them. What is the opinion of experienced scientists in information technology and university teachers regarding using AI tools to decide professional IT-related tasks, the implementation of which requires soft skills? Is using AI tools for soft skills development appropriate while training IT measures? And the next slide. So we can see the methods that were used in this research. Well, let me tell you some words about the methodology design thinking, which promotes the production of creative and innovative software solutions required for software development by means of simulating scenarios of real projects. All the methods that you can see have proven effective. Traditional curricula training programs pay much more attention to developing technical hard skills over soft skills, potentially leaving the shortcomings in the professional training of IT majors. The next slide. So it's important to remember that the world is moving forward, and new technologies, AI tools, can be applied so that AI professionals, IT professionals with lower soft skills can demonstrate higher level skills and be more productive in their work. AI is the trend in modern society and the point of interest for both students and teachers. Integrating AI into developing the soft skills of IT students is increasingly recognized as essential for students' future professional activity and successful fulfillment of working tasks. Recent scientist publications emphasize the potential of applying AI technology to improve the soft skills of IT majors. And then, okay, thank you very much. The terms that are used for characterizing soft skills vary in different sources. However, there are variations of these definitions, as can be seen in slide. So as of today, there are no established views in the list of soft skills essential for computer science students. However, many scientists, as well as document creators, such as the authors of the document, the criteria of accrediting engineering and computer program by Accreditation Board for Engineering and Technology, emphasize the importance of special skills. In particular, scientists highlight the importance of soft skills, such as communication skills, teamwork and cooperation, problem-solving skills, interpersonal skills, time management and organizational skills, self-management skills, leadership skills, creativity that encourages thinking outside the box and developing new solutions. So based on the analysis of research relating to the development of or enhancing soft skills in the professional training of computer science students, introduction chapter of the current research and the above list of the soft skills for engineering on computer programs by Accreditation Board for Engineering and Technology have been identified a list of soft skills for our study. This study employed the descriptive method and the expert survey method. Exploiting the descriptive method made it possible to analyze scientific papers and internet materials to determine the appropriate AI tools to performing professional tasks requiring soft skills. The expert survey were used to answer the research questions number 2 and 3. The target survey group consisted of IT specialists and university teachers who teach computer science students. Applying a qualitative research method made it possible to process collected data, analyze this data, and answer research questions. The point of concern mirrored in the survey was the use of AI tools to complete professional tasks involving students' soft communication skill ability. It was also important to consider the feasibility of using AI tools in the professional training of future IT specialists. Considering the results of a research of internet sources related to the use of AI tools for developing, improving, and then applying soft skills in the IT sphere, we have compiled the list of AI tools applicable to completing professional tasks in the IT industry. The results of the conducted analysis are presented in this slide. So we found out which AI tools, according to scientists, can be used by IT students to perform future professional tasks relating to the use of soft skills. This list has been expanded by analyzing internet sources to harmonize theory and practice with surveyed specialists in IT and university teachers who teach computer science students, and then we analyze the results. So the 30 IT specialists participated in the survey. 30% of the respondents have been working in the IT sphere from 10 to 20 years. 30% of the respondents have been working or have working experience from 5 to 10 years. 13% of surveyed IT professionals have been working or have working experience in more than 20 years. The same number of the respondents have been working in IT for 3-5 years, and some participants have been working in IT for not over 3 years. So most surveyed participants are experienced professionals with extensive backgrounds. To the question which AI tools or AI-powered apps do you use to help with work tasks that do not involve programming skills, most of the IT specialists responded AI chats. Many of the surveyed participants use AI-powered apps to work on improving the text and for text correction. Also, participants use these tools to effectively work with the involvement of AI technology. 10% of the respondents use it to work with projects, and some respondents work with AI art generators. Some respondents do not need AI tools for performing the tasks. IT specialists recognize that AI chats are valuable for training computer science students. In particular, the survey participants stated that using specific or particular sets of AI tools to perform professional tasks is appropriate. Hence, their sets of AI tools can be recommended for training computer science students. The list of these AI tools and their percentage is on the slide. We asked IT specialists about the purpose of using AI tools in training computer science students. Most of the respondents opted for 2 objectives. Number 1, AI tools allow students to optimize the teaching process and reduce routine work to be able to focus on more creative tasks. And number 2, AI tools give ideas to IT students for their study. AI tools help make teaching and learning accessible and compelling to everyone. Also, AI can contribute to the development of the students' creativity and innovative thinking of students. And using AI allows students to prepare more or to prepare for the future challenges of the IT industry and make them more competitive in the labor market. Moreover, AI tools support the intention of IT students to learn humanitarian subjects to improve or develop their soft skills, and AI tools make students aware of the latest technologies and trends. What matters is that more than 93% of the respondents said yes to the appropriateness of using AI in the process of professional training of future IT specialists. In this survey, 25 specialists in IT participated. Most of them have solid teaching experience. 32% of the respondents have been teaching from 10 to 20 years. And exactly the same quantity of the respondents has been teaching for more than 20 years. 20% have been teaching from 5 to 10 years, and 16% have not over 3 years of experience. To the question, which AI tools or AI-powered apps do you use to help with work tasks? IT teachers mostly answered that AI charts. AI-powered apps such as Grammarly are used in great demand. 52% of the respondents use them to improve the content of the text and for text correction. Microsoft Copilot has value for IT teachers. 40% of respondents chose it. AI art generators help 32% of respondents. 16% use AI tools for working with projects. Among the surveyed participants, only 4% do not use AI tools to make decisions. As AI teachers think, AI tools can be used to perform professional tasks that require applying soft skills. IT teachers' opinions on this matter are divided in such a way. 76% of respondents suggest using AI charts for this, and 56% of respondents offer to apply AI tools, AI-powered apps for improving the content of text and text correction. 32% use platforms for efficient work with the improvement of AI technology. The main reasons for using AI in the process of training IT students were identified by respondents as follows. AI tools give the ideas for IT students for their studying, 72%. AI tools make students aware of the latest technologies and trends, 60%. AI tools allow students to optimize the learning process, reduce routine work, and to be able to focus on more creative tasks, 60%. Using AI allows students to prepare for the future challenges of the IT industry and make them more competitive in the labor market, 56%. AI can contribute to the development of the students' creativity and innovative thinking of students, 44%. AI tools allow students to gain practical experience in solving real-world problems, 40%. AI tools support the intention of the IT students to learn humanitarian subjects to improve the development of soft skills, 40%. Some respondents believe that AI tools can or are necessary to train IT students. In their view, AI tools help them teaching and learning accessible to everyone and practical, 36%. AI tools foster the ability to work in a team, teach the students to work together in a team, use various instruments, and AI tools allow to accelerate the development of effective communication. Most of the surveyed IT educators consider that it is appropriate to use AI in the process of professional training of future IT specialists. Only 12% are not sure about this decision, and none of the respondents consider it inappropriate to use AI in the process of professional training of future IT specialists. In the process of analyzing of the opinions of IT specialists, we decided to determine the correlation between their experience of work in the IT sphere and the following two characteristics. Number one, the satisfaction rating related to exploiting the AI tools and applications based on AI at work, the conviction that the tools of AI can be used to perform professional tasks that require well-developed soft skills. So it has been defined that the more experienced in IT the respondents have, the more their satisfaction with AI exploiting, the more they agree that AI tools and apps are valuable in the process of training computer science students. The next step is to define whether there is a correlation between the work experience of IT educators and the following three characteristics. The satisfaction level related to the use of AI tools and apps based on AI. The conviction that the tools of AI can be used to perform professional tasks that require well-developed soft skills. The feasibility of using AI in the process of training computer science students. So it has been defined that the more teaching experience our respondents have, the more their satisfaction with AI exploiting, the more they agree that AI tools and apps are valuable for performing AI IT tasks, IT-related tasks that require well-developed soft skills. The more they agree that the use of AI tools and apps in the training process is considered appropriate. Today, there are AI tools that are applicable to deciding professional tasks in the IT industry, and they require applying well-developed soft skills. This is the first conclusion. The second is, based on the work experience of IT specialists and IT teachers, we made conclusion that AI tools are helpful to decide professional IT-related tasks, the implementation of which require strong soft skills. The third result is, based on the survey results, we can imply that most IT specialists and IT educators who participated in this survey support the idea that AI tools can be used to train computer science students to perform professional tasks, but implying well-developed soft skills. Among the four arguments claimed by IT educators are students' interest. Given the sufficient number of AI tools available today online, considering the requirements of the modern labor market that states multiple tasks for the IT specialist, the successful performance of which required good knowledge of new AI technology, along with the well-developed soft skills, also taking into consideration the fact that the experience of AI-powered implementation in the process of training computer science students exists. We conclude that the use of AI tools in the process of training computer science students is relevant. That's all that we wanted to present you today. Thank you very, very much for your attention.
Thank you very much. Please, dear colleagues, your questions to authors and speaker. The questions we can...
I see questions in Stack chat, and thank you for the questions. I think the best thing is joint project work and training for IT educators from leading experts. Questions from Tatiana.
Well, thank you. I call the questions for record. The research found a strong correlation between teaching experience and satisfaction with AI tools. What specific strategies could be implemented to help less experienced IT educators become more comfortable and effective with integrating AI tools for soft skills development? It's first question.
Okay. Which tools can be used, right?
Yes.
You mean which tools can be used? So we think that ChatGPT can be used, then Grammarly and Microsoft Copilot. Thank you for your question.
Well, another questions, please.
I have a question too. How can university combine teaching traditional soft skills with AI tools while making sure students develop real people skills instead of becoming too dependent on AI?
Thank you for your question. I think that the tasks can be involved in the process of training. So during the lesson, students can complete the tasks that need the performance, the completion of which need to use these AI tools. So this is the first step. Concerning the next steps, so I think that probably today, according to our research, according to the results of our research, I can't recommend anything. But if we are talking about lectures, if you are talking about lessons, so the implementation of the tasks that need the use of AI tools is possible.
Thank you for your answer.
Thank you very much for your attention.
I have a question. Soft skills are common of different specialists. Do you think the result of your study can be extended to the soft skills formation of other specialty students and teachers and students?
You mean, is it important for students or teachers, right? What do you exactly mean? I just want to clarify. So is it really important for teachers and students, yeah, to have these soft skills if we are talking about specialists in sphere of IT? Well, so is it correct? Yeah.
Okay.
Yeah, I think yes. I think that it's important according to our research to develop the soft skills for professionals in sphere of IT, and the use as our research confirms, the teachers use these tools. They use them during the lessons, so it means that, and they think that it helps to improve these soft skills. And concerning the soft skills that they're important or not, they're very important because today in this labor market, competitive labor market, it's not enough to know everything about the technical sphere of your work. It's quite important to speak to people, to ask the questions, to be ready to answer. And even in the sphere of IT, it is really important. Well, so if I understood you correctly, so I will try to answer. Well, thank you for your question.
Thank you very much. We haven't question. Thank you, Natalia. And our next presentation will be the site AI in education too. And I invite Tatiana Ivanivna Lysenko. Please, Tatiana.
Good day. Good day, dear college. My name is Tatiana Lysenko, and I represent Kremenchuk Humanitarian and Technological Academy. Today, I would like to present the finding of our study on how participation in artificial intelligence projects influence the cognitive competence of gifted students. Sorry for my English. If you have any questions, please submit them in written form via the conference chat. As we all know, AI is rapidly transforming both educational and the labor market. Young people need to quickly adapt to new technologies, work with large data sets, algorithms, and analytical tools. Cognitive competence, the ability to think critically, act creatively, and make a decision under uncertainty is becoming a key factor for success in modern society. Our goal was to analyze how development of innovative scientific AI projects fosters scientific thinking of students, creativity, and adaptability to the challenges of the modern technological environment. We focused on the following aspects: critical thinking, ability to formulate problems and seek solutions; creative thinking, development of new models and adaptation of algorithms; analytical skills, data processing, model selection; scientific thinking, hypothesis formulation, experiments, result analysis. We analyzed 7 student projects implemented at the Politlyceum between 2017 and 2024. The evaluation of projects was based on the criteria of the Junior Academy of Sciences of Ukraine. The students' giftedness was determined through self-assessment using the personal factors of giftedness methodology recommended by the Institute of Gifted Child of the National Academy of Educational Science of Ukraine. Before the start of project work and after its completion, the development of components of cognitive competence was assessed using rating scales of giftedness, indicators recommended by the same institute. Students' projects applied diverse technologies such as swarm intelligence algorithms, artificial neural networks, computer vision, natural language processing. Each project demonstrated clear development of cognitive competence. For example, Battle of Generals, an AI-powered game using swarm algorithms, development of the critical and analytical thinking; digital recognition, a custom-built neural network for handwriting digit recognition, formation of scientific thinking; NeuroMath, a system for recognition mathematical expression with 3 neural networks, enhancement of creative and analytical skills; Smart Home Assistant, a voice-controlled assistant for smart home management, integration of cloud technologies; Transziffer, a traffic scene recognition system, use of OpenCV and neural networks; Nova Assistant, a voice-controlled assistant for controlling computer devices and interacting with users. garbage eye, and dive guard, computer vision systems for environmental monitoring and underwater navigation, implementation the YOLO models, cloud technologies, and GSHARE recognition. We conducted a comparative evaluation in the described projects according to the criteria used in the competitive selection process of the Junior Academy of Sciences of Ukraine. The analysis result revealed a correlation between the level of systematic topic coverage and the ability of think creatively. This relationship indicates the deep engagement with the research topic directly contributes to the development of analytical thinking. The dynamics of research competence development particularly evident in the comparison of two projects by the same student, Garbage Eye and Dive Guard, where growth across all key indicators is observed. This demonstrates the gradual formation and increasing complexity of cognitive competence through project-based work. To assess the impact of project-based activities on the development of students' cognitive competence, an expert evaluation was conducted using rating scales of intellectual, creative, and practical giftedness. The level of each type of giftedness was measured before and after the project, allow for a comparison of change over time. We recorded 13% growth in cognitive competence, especially in analytical and scientific thinking. Thus, participation in the development of AI projects develops critical, creative analytics and scientific thinking, fosters skills in analysis, adaptation, and decision making, increases motivation for learning and scientific research. This skill are not only valuable for education, but also highly relevant for the modern job market, while fostering an understanding of the nature and potential of AI technology management. Our experience confirms the effectiveness of integrating AI-based projects activities into the educational process, especially for gifted youth. Thank you for your attention.
Well, thank you very much. We have two questions. First,
Maybe I will be the first. And for second question, authors can write answer on the chat. And my question, what are the risks of using AI in student project?
Thank you for your questions. Risks for using AI in students' projects is models error or bias, ethical consents, legal and age restriction, addressed through discussion, documentation, and parental consent. That's all.
Thank you.
А другий?
Зараз чекай. Це з чату. Це вона задала наше питання. Це з чату. Поки що всі мовчать.
We can answer the question in the chat too, but I want to read the question in voice for record this section of conference. First question from Tetiana Vakaluk. The study demonstrates positive outcomes in cognitive competence development through AI project participants. But how might these benefits be expected to students who aren't already identified as gifted? Could the project sorry. Could the project-based learning approach with AI be adapted for more diverse student populations? And second question, the research mentions various challenges, including legal restriction, potential AI errors, and balancing formal education with project work. What specific strategies could educators implement to overcome these limitations while still leveraging AI projects for cognitive development? Please, you can answer the questions through conference in the chat.
Thank you.
Well, thank you.
Yes, the benefits of AI-based projects learning can be extended to a broader student population. Project-based learning involving AI can be adapted to various skills levels by simplifying tasks, offering scaffolded guidance and incorporating collaborative work. This inclusive helps faster critical and creative thinking among all students, not just the given owners. And second, educators can overcome these challenges by involving parents early for legal consent, using age-appropriate AI platforms, and teaching digital ethics to handle AI limitations. Scheduling project work during extracurricular for the integrating it into existing curricula helps balance academic load while promoting cognitive development. Thank you.
Thank you. Thank you very much. Have another question, your colleagues? Thank you, Tetiana. And I want to invite for next presentation Irina Krishninik, creating our collaborative learning framework for computer science students training in the field of database design. Please.
Hello.
Interesting presentation.
Yeah. Some seconds. Do you see it, my presentation?
Yes.
All right.
Now you can see it. Oh no, no.
Yes, we can see the presentation.
Ah.
Thank you so much.
We see PowerPoint window.
Please try основне in
Oh,
menu.
yeah. Так. Sorry, I have some monitors and some problems to check it. And now presentation of PowerPoint or
Спробуйте в меню вкладка «Основне», подивіться, в лівому верхньому куті. І ще трішки, трішки від файл праворуч. «Основне». В лівий верхній кут.
У мене зум трохи заважає.
Перетягніть ту менюшку.
Ось так. П'ять. Та ну що ж таке? Can I show this presentation too? Hello, dear colleagues. Today I'm honored to present you the results of the scientific work titled Creating of Collaborative Learning Framework for Computer Science Students Training in the Field of Database Design. Professional activity in the field of information technology involves interaction with colleagues, managers, and clients. Well-developed soft skills can ensure its effectiveness and reduce stress. Such skills should be developed during professional training, particularly in higher education institutions. This can be facilitated through teaching methods and technologies that encourage active interaction among participants. Collaborative learning is a powerful method for forming and developing skills essential for teamwork. The aim of the study is to develop a collaborative learning framework based on the analysis of scientific sources, to conduct its pilot implementation, and to identify directions for its improvement. The research consisted of such main stages: search and selection of scientific publications on collaborative learning and database training methods, analysis of selected scientific publications using WOS viewer software, development of a collaborative learning framework, and empirical study. Our framework based on the following methodological approaches. The first, group work. The teacher forms groups randomly or taking into account factors important in a particular case. The group independently chooses the subject area for database design and organizes its activities. The teacher monitors whether students adhere to the principles of activity, distribution of leadership, and responsibility for the overall result. The second, jigsaw technique. The teacher uses it for theoretical training of students. Students consolidate and deepen their basic knowledge of conceptual, logical, and physical database design. The third, peer learning. Students who are experts in specific aspects of database design explain and the learning material and provide necessary assistance to other group members in the process of completing tasks. The fourth, self-assessment and peer assessment. At the end of the work, students evaluate their own results, the results of the work of other groups, and their contribution of each to the overall result of the group using special criteria. There are three-phase jigsaw implemented in this study. The first, individual phase. Teacher assigns randomly one database design level, conceptual, logical, or physical, to each student. Students must revise educational content and read the documentation. This phase is completed as homework with approximately 2 or 3 hours. The second, expert phase. Students are grouped with other experts on the same database design level. They discuss some complex aspects and strengthen their knowledge. This phase goes on for 1 or 2 hour class session. And the third, jigsaw phase. Teacher creates randomly groups from 3 students. Each of them is expert on the one database design level. Students must explain to the other group members their knowledge. This phase also goes on for 1 or 2 hour class session. In this slide, you can see the collaborative learning framework flowchart. The main stages of the framework are the first, obtaining of theoretical knowledge of primary practical skills. The second, selection of the subject area. The third, conceptual database design. The fourth, logical database design. The fifth, physical database design. And the sixth, presentation of results. And the final, seventh step, evaluation of results. In this slide, we present assessment algorithm. To determine the overall score of the project, we use the equation which take into account teacher assessment grade, self-assessment grade, and peer assessment grade with weighting factors. To determine the individual student grades, we use the next equation, which takes into account teacher assessment of students' contribution, self-assessment of students' contribution, peer assessment of students' contribution, and overall score for the project with weighting factors. Teachers' preparation for implementing collaborative learning technique in database design training should include the following steps. The first, determine the amount of training material sufficient to form a theoretical and practical basis for group work. Prepare the necessary methodological materials. The second, determine the number of hours classroom and independent work for each stage. The third, determine the criteria for evaluating the results of group work. The fourth, select software tools and online environments for group work. The choice of training tools depends on the specifics of the educational program. The framework was implemented during the teaching of bachelor course databases and information students. 32nd year students participated in the study. To perform database design tasks, 7 groups of 3 students each were created, and the other 9 students worked independently. We worked in distance form. The following tools were used: DBMS MS SQL Server, MS SQL Server Management Studio, a training course on the website of distance educational technologies, and platform Discord for communication. Students evaluated the following parameters on a 20-point scale: the quality of their own team's project, the quality of projects of all other teams, the effectiveness of their own activities, and the effectiveness of the activities of other team members. In the slide, the distribution of individual students' grades by levels of performance is shown. It can be assumed that students who worked in groups completed better quality projects and received higher grades. However, using Mann-Whitney U-test showed that there were no statistically significant difference between these groups. At the same time, students who worked in teams gained experience in teamwork, awareness of its advantages and difficulties, and skills in peer learning, self-assessment, and peer assessment. After completing the project activity, students rated their level of satisfaction with collaborative learning using Likert scales. The results of the evaluation are presented in this slide. In general, it can be concluded that most students are satisfied with the teamwork, the results, and the experience. And in the end, the research results have the following limitations. The framework is aimed at developing database design competences, but the database professional training curriculum covers significantly more content. And the framework was implemented within one training course, so the conclusions obtained cannot yet be extended to all education institutions. And the framework needs improvement on the following areas: improving methods of organizing and controlling students' teamwork, and developing convenient tools for self-assessment and peer assessment of teamwork results. That's all. Thank you for your attention. Please, your questions.
Thank you very much. We have a question in the chat. Since the study found no statistically significant differences in performance between individual and collaborative learning groups, that specific modifications to the framework could potentially lead to measurable improvement in learning outcomes for collaborative teams. How could, and another question maybe, how could the collaborative learning framework be expected beyond database design to other areas of computer science education, where teamwork is essential for professional success? And what adaptations would be necessary for different subject domains?
Thank you for these questions. Our empirical study was pilot and as I say, only in one course. So, because we work in distance format, and our students had some limitations of such work, and they don't have enough skills and enough skills in collaborative work. So the level of quality of design, the database design, were enough equal of students who work independently and students who worked in groups. So we think, and in our conclusions we show that it is necessary to improve methods of organizing collaborative work and to train our students to work in teams. We think that the more students have such experience, the more the results will have higher quality. Now we have such results, and we want to work and to improve our framework. And if we say about other computer science areas, this framework can be adapted to other areas if if we take into account characteristics of these areas. For example, if we want to teach game development, we can design necessary steps for this framework, but these steps will include theoretical training, practical training, then steps for game development, and then evaluation, presentation of results, and then evaluation. And for us, very important are techniques of evaluation, peer assessment and self-assessment, and group assessment.
Thank you. Thank you very much. Please, another questions, colleagues? Little questions from me. What do you consider to be the optimal composition of the group of students working at the same project? I mean the number of students and their role in the group.
For our project for teaching database design, we think 3 students is optimal number, because we on this stage we teach only design, not to develop software. But the next stage is to teach development programs with database, and on this stage the groups of students can be can have more students, maybe 5 or 6 students, because the bigger groups we think will have some problems and difficulties in organizing team activity.
Well, thank you very much. Thank you for your report and presentation and your study. And for next presentation, I invite Lyudmila Gryzun, computational and algorithmic exploration of polygonal numbers, their role in computer science education. Please, Lyudmila.
Okay, thank you. Hello to everybody. I'm happy to greet all the participants of our conference. And my name is Lyudmila Gryzun. I'm Doctor of Pedagogical Science, full professor of Information Systems Department of Simon Kuznets Kharkiv National University of Economics. The topic of my presentation today is computational and algorithmic explorations of polygonal numbers and their role in computer science education. So in terms of my presentation, I am going to cover the urgency and purpose of our research, theoretical framework, development of dynamic computer models and proper dynamic support for the students' engagement into computational and algorithmic explorations, investigation of the benefits of the students' engagement in terms of their awareness of math knowledge value for their professional activity, and the discussion of the results. So in terms of the urgency of my study, so I could distinguish two main contradictions which we can maybe which are obvious nowadays. On the one hand, there is urgent needs of society to raise the level of the computer science education based on mathematical background exactly. And on the other hand, we can observe falling students' motivation to learn mathematics deeply and to understand the mathematics value for future IT career. And second contradiction, as I can see, there is great cognitive power of mathematics as a science, and on the other hand, unfortunately, insufficient using of this power in computer science education in order to develop analytical skills, scientific skills, critical thinking for students, and so on. So what are the possible ways of resolving these contradictions? To my mind, it is necessary to find out some proper mathematical and didactic mechanisms with IT tool using in order to do what? To demonstrate true practical values of abstract mathematical concepts for the students, to provoke students in eagerness to computational explorations, and in such a way to raise their awareness of math and algorithms knowledge value. So why exactly the concept of polygonal numbers should be used on this purpose? Well, first of all, the concept of polygonal numbers can be considered both as an example of cognitive resource of mathematics and its application to didactic and real life as well. So polygonal numbers can be seen everywhere, both in nature and in real world and in industry and so on. and technology as well. On the other hand, polygonal numbers as a result of formation of the series of composed from the sums of arithmetic sequences with geometric interpretation, they can be seen also the sequences of regular polygons made of dots. And as you could see, the explorations of polygonal numbers got quite long history, starting from the 3rd century before AD, and then they got some of the explorations or evolution of the explorations in the works of further quite great and eminent mathematicians. However, despite this long history, important relations between flat polygonal numbers have not obtained detailed research, and on the other hand, significant educational value of polygonal numbers has to be explored and used due to the some reasons. They allow students to realize a link between geometrical and algebraic essence of a number as it is, to trace the continuity of geometry and algebra methods in mathematics, and to see applications of an abstract notion to practical problems solving in math and computer science. All of these things pushed us to do and obtain some relations among flat polygonal numbers and explorations of their properties as algebraic systems, which made, in fact, the theoretical background of the whole pedagogical research, like, let's say. Based on this theoretical background, we developed proper computer models and elaborated necessary didactic support for the students' engagement in computational and algorithmic explorations. And finally, we were eager to investigate the benefits of the developed tools for the pre-service IT specialists in terms of their awareness of math and algorithms value for their future professional activity. Here you could see some basics and research methods which have been used, and I'd like to represent in brief a theoretical framework based on existing research, starting from primitive triangular numbers, which are seen as a correspondence of each triangular number to expressing an amount of points in it, and in such a way it could be obtained numerical sequence. In the same way could be obtained quadrate and pentagon numbers, and according to studies, the all polygonal numbers can be put into infinite table with calculation of the general number, and according to, again, to the existing research, general formula of k-angular number with index n can be seen in such a way. Pushing from this general evidence in the field of polygonal numbers, we obtained a set of quite important mathematical results which make relations among polygonal numbers based on their properties investigation. Some of my mathematical results may be characterized as follows. First of all, we obtained the general formula of difference between k-angular and k-1 angular number, and also the general formula of calculation of any k-angular number via the nth triangular number. Also, it was obtained the relation between pentagon and quadrate number, generalization of famous Diophantus relation. It was generalized in such a way, which, as you can see on the screen. Also, we got geometric interpretation, and pushing from this one, we extended to the result number 3, and based on exactly geometrical interpretation of this generalization. Also, they were obtained relations between triangular and pentagon numbers, as you could see on the screen, and again they were a bit modified based on the geometric interpretation of this our formula. Finally, in terms of exactly mathematical results, it was done the determination of binary algebraic operations on the sets of polygonal numbers of various angularities. And in particular, it was established the binary operation of addition on the set of polygonal numbers with angularity k, and the binary operation of multiplication. So it was concluded also that these operations, binary operations, they are invariant with respect to the angularity of numbers. And also some of algebraic properties of the sets of polygonal numbers were established and analyzed. So based on this mathematical background, then this mathematical background was implemented for the creation of dynamic computer models, and also preparation of special didactic support exactly for the students' engagement into computational and algorithmic explorations. So this work, these explorations can be characterized in step-by-step way. For the first stage of these explorations, students were involved in work with ready-made dynamic models of polygon numbers built by us in GeoGebra software. Students had to manipulate models and solve the set of proposed tasks, as you can see it on the screen. All of these models were supported with so-called sets of heuristics, which encourage students to make their own manipulations with models and checking their hypotheses and making their own understanding of these regularities. Students were encouraged to combine in one model numbers of different angularities and pushed with some questions in order to understand and make their own conclusions. Second stage, it was so-called constructive way to use polygonal numbers phenomena to progress students' motivation and awareness. The task was mostly to locate proper amount of dots in the shape of a proper regular polygon and to obtain geometrically similar and overlapped polygons in order to make, first of all, for students, it was quite a learning challenge to figure out the regularity and find out the way how to visualize this regularity using computer. And in fact, again, they used GeoGebra environment, but in order to construct their models, not to use ready-made models, but to construct their own models, again, using the chain of so-called partition questions and heuristic, which help them to build finally universal model of polygonal numbers of any angularity based on the chains of subtasks and with potential via analysis. Here you can see some episodes of students' work and students' manipulation with their built models, which also encourage them to algorithmic and to computational explorations. Then students were involved into the spreadsheets work on building universal tables in order to investigate the action of binary algebraic operations of addition and multiplication. And finally, on the fourth stage of this work, students were encouraged to solve the set of algorithmic tasks combining algebra, geometry, and computation. And these tasks were from basic and let's say easy tasks, like develop a program that calculates the nth term of any k-gonal number with special requirements. These tasks, extension, and some other tasks like creating a graphical representation of the first n terms of specified k angular number. again with extension of this task, and step by step these algorithmic tasks were how to say it, made encourage students to more creative algorithmic solutions, included the problems of analysis of the and identification of patterns in the differences between consecutive k-angular numbers, exploring higher order differences, comparing different algorithms for generating k-angular numbers in terms of the time complexity and space complexity, and so on. And finally, it would be recommended, and we partially done it, to emphasize nowadays implications of polygon numbers and their computer models. We involve students in more practically applied practically driven projects to solve the set of quite complicated problems. For example, it was tackled the problem of determination of maximum amount of equal figures located inside of specific shape and its derivation. Then time series smoothing based on polygonal numbers, and applied the investigation for indicators of find markers, for example, genetic algorithms on the basis of triangular numbers, which are used in AI, and some other practically driven tasks and projects. So intuitively clear that such an activity is really beneficial for the pre-service IT specialists in terms of the awareness of mathematical knowledge value in their professional activity, and on purpose of understanding the impact of the set explorations. So it was prepared and conducted the survey and monitoring program, which allowed to reveal the changes in the level of the students' awareness and to understand how, in fact, students took such an activity, how it was beneficial for them in this sphere. So there were established 3 levels of formation of the IT specialist: awareness of mathematical knowledge, reproductive, productive, and creative. And for each of the levels, we also formulated some indicators which allowed us to identify if really a student reveals his awareness on reproductive, productive, or creative level. So our monitoring, according to the prepared program, testified the raising of the students' motivation and tendency to comprehend the essence of mathematical background of a problem, and growing their attention to algorithms building in the course of software creation. In addition, we held the survey, which aimed at revealing the hindsight reflection of their work upon the exploration and modeling tasks, and to characterize and brief the selectively results of our survey. I have to say that about 75% of our respondents, they admitted that doing explorations with polygonal numbers in GeoGebra and via coding tasks encouraged them to apply mathematical knowledge in a more concentrated and more conscious way. Over 60% admitted changes in their understanding of the practical value of mathematical knowledge for exactly the software development. 70% said that such an activity provided them with precious experience of math-based investigations in practically significant tasks. And some results of the changes of in distribution of pre-service IT specialists, but the levels of their awareness, so we can conclude that the number of students who revealed reproductive level of the awareness decreased by 2%, productive level decreased by 4%, and the number of students who revealed creative level of the set awareness increased by 7%. And summing up my presentation, I'd like to say that possible benefits for students, as for my own feeling and as for results of my own monitor, and I'd say that these benefits are, first of all, holistic view. This activity promoted forming of the holistic view of students at our world, integrative understanding of mathematics and computer science, integrative role of mathematics as a universal language for reality description. Also, its aspect of philosophical historical outlook, it was also quite obvious for me that it influenced on students, definitely. Their skills of recurrent relations obtaining, modeling and coding skills, also such an activity was really beneficial for the students, and we go on working in this sphere. Thank you for your attention. That's all, and I will be happy to answer your questions, if any. Thank you.
Thank you very much. Please, questions.
I have a question. Maybe
Yeah,
I will
thank
be
you.
first.
Yeah, you're welcome. Thank you.
How can we use polygonal numbers to solve real problems that IT companies face today, helping computer science students connect math concept to actual job tasks?
Some of them I have already mentioned during my presentation. The matter is that there are quite a lot of spheres that where polygonal numbers are still topical in order to, for example, the maybe most obvious way to use them here and to use exactly this their properties. There is the decreasing of the degree of time series, which has really great importance in fund markets and so on. That is one of the ways. Then also polygonal numbers are widely used in cryptology and in generative algorithms. Also, there are quite a lot of significant applications. So there are quite a lot of examples and a lot of research done where students can be also involved. And the brightest example of using of polygonal numbers can be also the covering of cell covering, and the cell topology of cell nets also is based on or it may be based also on polygonal numbers, and they are geometrical, both algebraic and geometrical sense or essence.
Thank you for very informative answers. And
Yeah.
I have a second question. Besides surveys, how can we measure if learning about these math concepts actually helps students in their jobs after college and in solving hard problems?
In other words, you mean how to say it, beyond measuring? What do you mean beyond measuring? How can it help?
Yes.
I think that why exactly I started doing this, let's say, project, I think didactic project, because I could see that nowadays new generation of IT students, they definitely underestimate the role of mathematics and role of computational explorations, algorithmic explorations in their future career. They look at AI education like something which will help them immediately to start working in big companies and work with how to say it, using programming, coding without mathematical background. That is common delusion of new generation of IT students, unfortunately. They underestimate it. They rely mostly on different libraries. They think that everything is already programmed and they can take it, use it, and that's all. However, my aim and my mission as a computer science professor to demonstrate students that it is not enough just use ready-made something. If you want to be progressive and want to be advanced developer in future, you need to have this mathematical and algorithmic feeling and computational and analytic skills. And in order to do it, how to gain it, you need to use and to learn mathematics and to use mathematical explorations in your professional work. And there is first steps to show them how to do it and why it is important. Thank you.
Thank you for very complete answer.
Thank you very much. Another questions, please? Oh, well, we have not question. Thank you, Ludmila.
Thank you. Thank you. See you. Very nice to see everybody. Thank you.
And for next presentation, the topic integrated game development into the secondary school informatics curriculum, a case study from Ukraine. I invite Alexander Kruglo. Please.
Yeah, do you hear me?
Yes,
Yes.
yes.
Okay, first of all, I would like to apologize about lack of web camera because I feel a little bit thick, but hope it's okay. So, how we can start? First of all, I would like to speak about video game industry in total. The video game industry has experienced tremendous growth in recent decades, becoming a significant driver of technological innovation and economic activity. Global games revenues exceed 180 billion in 2024, with mobile gaming accounting for nearly half of this total. The increasing size of sophistication of games have generated high demand for skilled developers. To meet this demand, a growing number of universities offer game development courses and degree programs. These programs often emphasize hand-on development using industry standard tools such as Unity, Unreal Engine, etc. While the growth of post-secondary game and development education has received considerable research attention, further studies have examined teaching these concepts at the secondary school level. Incorporating game development into secondary computing curricula present both opportunities and challenges. Now we speak about informatic education in Ukraine in total. Informatics is a mandatory subject in Ukrainian secondary schools, spanning grades from 5 to 11. The curriculum aims to provide students with a foundation in computer literacy and problem solving. Schools have the flexibility to offer additional elective courses to extend and deepen students' learning. Common electives include the web development, robotics, and 3D modeling. However, game development has not traditionally been part of the standard informatics curriculum. Now we can see several challenges about integration computer education in Ukraine. Efforts are underway to modernize the informatics curriculum and teaching methods. These include new standards emphasizing competencies over content knowledge, investment in school computer labs and professional development for teachers on new technologies. Elective courses provide the mechanism to pilot new topics and approaches within the exciting curriculum framework. The current study aims to build on this limited prior work by investigating the implementation of a Unity game development course within a Ukrainian secondary school informatics program. The goal is to provide the proof of concept for feasibility and value of teaching foundational game development skills in this context and to generate recommendations for future practice and research. So about resource questions, to address resource question, a case study methodology was employed, focusing on the design, implementation, and evaluation of game development course at a single school site. Both quantitative and qualitative data were collected to provide a holistic understanding of the course and its outcomes. The study site was a public secondary school in an urban area of central Ukraine. The school has approximately 500 students in grades of 5 to 11 and offers standard national informatics curriculum. The elective course was offered to students in grades of 10 to 11 who had completed the core informatics curriculum. These students have prior experience with block-based programming in Scratch in grades from 5 to 6 and text-based programming in Python from grades to 7 from 11 to 11. So let's speak about course overview. The course was designed as a one-semester elective meeting for 45-minute lessons per week. The goal was to introduce students to foundational game development concepts and tools taught hands-on experience creating simple games. The Unity game engine was chosen as a primary development platform due to its widespread industry adoption and intensive learning resources and free education licensing. The first part of the course followed a structured sequence introducing K-Unity concepts and techniques, taught interactive demonstration and mini projects. Each lesson typically included a brief lecture or demonstration followed by hands-on student work with a teacher support. Weekly assignment had students implement specific features in their own projects. In the second part of the course was more open-ended, with students designing and developing their own small-scale games based on a theme or genre of their choice. Let's speak about game development, about course elements. The course concluded with students presenting their completed games and reflecting on their learning experiences. Games were evaluated on technical functionality, creativity, and user experience, with the goal of providing constructive feedback rather than grading. The pre- and post-course surveys include Likert scale, items measuring students' self-assessed knowledge of game development concepts, comfort with Unity, attitudes towards game development, and future learning intentions. Open-ended items request feedback on the course content, structure, and teaching approach. Surveys were administered online and were optional and anonymous. Student survey responses indicate significant gains in self-assessed knowledge of game development concepts and tools. On a 5-point scale from no knowledge to high knowledge, The mean rating increased from 1.8 on pre-survey to 3.9 on the post-survey. By the end of the course, all students successfully completed playable mini-game. Games spanned a range of genres. Let's speak about recommendation emerged from the study. The result of this case study suggests that integrating game development into secondary school informatics education is feasible and can positively impact student learning, engagement, and attitudes. Students successfully learned Unity concepts and tools and applied them to create their own games. At the same time, the study highlights challenges in implementing games development education at the secondary level. The technical complexity of professional tools like Unity can be a barrier for both students and teachers. Careful instruction design is needed to manage cognitive load and scope project appropriately. Schools may also lack the necessary hardware and infrastructure to support intensive game development work. At the end, let's do some conclusion. More broadly, the study suggests the need for greater alignment between secondary computing education and the realities of the professional software industry. With the growing economic and cultural importance of game and interactive media, exposure to these domains can help prepare students for future career and engage them in computing when it is most relevant to their lives and interests. Despite the finding generalizability being limited by the small sample size and single school context, the study offers a proof of concept to integrating game development into secondary informatics curricula. Thank you for attention.
Thank you very much. Please, questions, dear colleagues.
We have the question on the chat from Andrei Struk, and have second question from Olena Tarasova.
Well, I read my question. Do you think that game development should be a part of the compulsory curriculum or part of the optional education?
I'm almost sure that that should be part of optional education because not everyone would like to do it, need in the future, and etc. Because game development, it's I'm almost sure it's not a mistake to say that it's hard work and can cause some challenges for programmer and do it compulsory curriculum is should be mistake.
Maybe development more casual games can take the part of compulsory curriculum. Without,
I think, yeah,
without
understand,
Unity
but I think we have something like that in our already curriculum, like Scratch. We can, it's maybe more about algorithm and something like that, but we can say that it's a little game, and if you interested in this and you would like to get deeper knowledge, you can use optional education and teach it more.
Well, thank you. And I read aloud next question. In your opinion, what factors contributed to the success of the course?
I think the most important of them is exciting and motivating nature of game development itself, and students should be excited to create their own interactive experience and see how their ideas implemented on screen. This internal motivation helped them to survive in difficult concepts and technical obstacles. Another success factor, I think, it's use of a structured but flexible curriculum that allowed for students choice and creativity. The first half of the course provided a solid foundation in Unity concepts, taught guided projects, while the second half gave students the freedom to design their own games. I think that's all about this question.
It's another question.
I have a question too. Did you encounter any problems during the course?
Yeah, during encounter there are some problems. While the overall implementation of the course was successful, several challenges were encountered, and one of these was a wide range of prior programming experience among students. While all had some exposure to Python, some struggled with the transition to C# and object-oriented programming concepts used in Unity. In this case, the teacher had to provide support for the students while also keeping more advanced students engaged. Another challenge was the complexity of the Unity interface and the wide range of features available. Even with a focus on 2D games, students could easily become overwhelmed by the options and menus. And one of the biggest problem it's technical that were encountered particularly with the school aging computer lab, and to solve this problem we had to use recover lower resolution graphics and older version of Unity.
Thank you.
Well, thank you very much.
Thank you for your questions.
So I want to invite for next presentation about using game development in education too. Alexander Poznyakov.
Good afternoon, everyone. Before when I start, I want to send in chat a link on a workshop about what I will say. Yeah, my SEM name development of. Oh, sorry, I forgot. Yeah, my SEM name, development of a Pygame workshop for extracurricular computer science education. I'll be presenting our research on developing a Pygame workshop for extracurricular computer science education. With the rapid growth of the gaming industry, teaching game development has become increasingly relevant in educational context. Our research identified a significant gap between student interest and available extracurricular programs in Ukraine. Many exciting programs use outdated tools, rarely on expensive software or recommended Russian resources, which is unacceptable in our current educational environment. Our study began with an analysis of student demand for computer science education. We examined data from the Junior Academy of Sciences contest in Dnipropetrovsk Oblast from 2014 to 2024. This graph depicts participation trends in the multimedia system, educational and game programs section across a decade in the Dnipropetrovsk region. The data covers the section which was part of the computer sciences department from 2014 to 2022. Starting in 2023, the department was renamed to Information Technologies, with the section also changing to educational, game programs, and virtual reality. Throughout this period, the data demonstrated that this has consistently been the most popular section, showing sustained and significant student engagement year after year. Notably, student interest remained strong even during challenging periods like the COVID-19 pandemic and following Russia's full-scale invasion. This second graph presents the percentage of multimedia system educational and game programs participants relative to all computer science direction. You can see that game development consistently attracts a substantial portion of students' interest in computer science. Typically, around 40% of all participants choose this specific area. However, when we analyzed the educational programs recommended by Ukraine's Ministry of Education and Science, we found significant problems. This table presents our analysis of exciting extracurricular education programs. As you can see, while some programs like Fundamentals of Computer Graphics and Multimedia System touch on game-related topics, none offer comprehensive game development education. We identified several critical issues. Outdated technologies like Adobe Flash and Borland C++ Builder. Inconsistencies between programming languages and tools. Expensive paid resources create barriers for students. And most concerning, all reviewed programs contains references to Russian literature and service. We also examined exciting Ukrainian educational courses that specifically use Pygame. First, its formula platform offers a free Pygame course but lacks a clear game development focus and has poor navigation. This Svita, a structured course with 5 modules but lacks visual examples and has formatting issues. IT Hub offers a comprehensive course, but at 2,400 hryvnias per month for the 3 months, it's extremely expensive. This analysis highlighted the need for an accessible, well-structured Pygame workshop that addresses this limitation. Next, it's based on these findings, we develop a Pygame workshop that addresses this issue. We choose Python and Pygame for several key reasons. Python's popularity and accessibility, its active use in schools for teaching programming fundamentals, simple syntax that allows beginners to quickly master programming basics. Pygame's portability across platform and operating system. Its modular structure ensures good code organization. The workshop follows a project-based learning approach and was implemented as a website using Google Sites. This format provides easy access to learning materials, code examples, and resources. The workshop is structured as a step-by-step guide, setting up the development environment, creating the game world, adding game character, player and enemy types, creating game object, lava blocks, first aid kits, ammunition, implementing game mechanics, movement, interaction, shooting, health, finalizing the game, adding menus and final touches. All material, including images, videos, and complete code, are available on a dedicated resources page with the full game code hosted on GitHub. To validate our approach, we conducted an observation with first-year students from Group E24 who were studying Python. After completing the workshop, participants provided feedback through a comprehensive survey. The quantitative results showed strong positive response. Course met expectation, 4.6 point from 5, quality of examples 4.7 from 5, interest in creating their own game 4.7 from 5, satisfaction with result 4.5 from 5, desire to continue studying game development 4.4 from 5. The material difficulty received a moderate score of 2.6 from 5, indicating an appropriate challenge level for the target audience. Qualitative feedback further confirmed the workshop's effectiveness, with participants highlighting its practical value in creating their own game projects. Our research demonstrates that Pygame is an optimal solution for the teaching game development in extracurricular education. The step-by-step structure of our workshop, combined with its practical orientation, makes it accessible and engaging for students. The workshop successfully addressed the limitation on existing program by using free, modern, and accessible tools, providing a logical progression of learning steps, focusing on practical game development skills, offering comprehensive resources and examples. The practical significance of this work lies in its potential for integration into coding clubs, groups, or individual training. The workshop helps students develop logical thinking, creativity, and fundamental knowledge of game development. Our results show that developing specialized courses like this Pygame workshop is an important step toward improving extracurricular education, adapting it to student interest, and keeping pace with technological development. Thank you for your attention.
Thank you for very interesting report. And I have a question. I see your site and I see that your course has 6 themes.
Yeah.
How many hours is the course designed for?
It's not a lot of when created this site, it's really fast. I need 1 day for this, yeah, but for create this site.
It's completed course or
it's
begin
only
of
site.
the course?
It's it's for complete course. Yeah, it's without game, without create game. It's just site.
It's a course for student the first year or
This course can be added for not only student first year, it can be added for a student school children, for children in school who finished module cycles in Python and function.
But in your research, you have opinion from your course from students group
24.
24.
Yeah, it's was for approbation. We add this course because now students studied not now studied Python in the time, and it was good practice for the student.
Okay, thanks for your answer. Maybe anyone else has a question? No question, and let's go. And our next report, development of an elective course on Scratch programming for specialized computer science education and Lyceum, and Karina Rezhanina. Let's start, or maybe Olena Tarasova.
Thank you. Sorry, the report was actually supposed to be presented by another speaker, but allow me to introduce myself. See you my presentation.
Yes.
That's
Yes.
all? That's all? Thank you. Good afternoon, dear organizers and conference participants. My name is Olena Tarasova. I am an associate professor of the Department of Informatics and Applied Mathematics of the Kryvyi Rih State Pedagogical University. I would like to present to your attention a paper, development of an elective course on Scratch programming for specialized computer science education in Lyceums. My co-author is Karina Rezhanina. She is graduate of the master's degree program, Computer Science Programming at the Kryvyi Rih State Pedagogical University. I would like to present to your attention our paper. Let's begin with the introduction. In the evolving landscape of K-12 education, the introduction of programming skills through block-based environments such as Scratch has become increasingly common. Scratch, developed by the MIT Media Lab, is a visual programming language that allows users to create interactive stories, games, and animations by dragging and dropping code blocks. This study aims to address the gap for more focused research on how Scratch can be effectively used in specialist computer science programs, particularly in Lyceums, which are specialized secondary schools. Our study focuses on fostering algorithm thinking and digital competencies. As mentioned, the integration of programming skills is increasingly common in K-12 education. Block-based environments like Scratch offer a visual and accessible way to learn programming. Scratch allows users to create interactive stories, games, and animation using drag and drop code blocks. While Scratch is popular, more research is needed on its effectiveness in specialized computer science education. Specifically, there is a need to explore Scratch's role in Lyceums, which are specialized secondary schools. Our study focuses on developing and evaluating an elective Scratch course for Lyceum students. The course aims to foster algorithmic thinking and digital competencies, and the course uses project-based learning and achieve these goals. Now let's look at the literature review. A systematic review by Batny et al. Analyzed current research trends in using Scratch for K-12 education. The review found that Scratch is commonly used to teach programming concepts across different subject areas and that studies generally report positive impacts of integration Scratch programming into K-12 curricula. However, it also highlighted the need for more comprehensive longitudinal studies. Moving on to the methodology, our study consists of the following key components: course design, participants, and a 12-week experiment. The elective course was designed with 6 modules, including Introduction to Scratch and Programming Concepts, Algorithms and Problem Solving, Variables and Data Types, Conditional Statements and Loops, Functions and Modularization, Project Development, and Presentation. Our course was designed to foster several key computational thinking skills. These include algorithmic thinking, which is the ability to develop a step-by-step solution to a problem, problem decomposition or breaking down complex problems into smaller, more manageable parts, pattern recognition, identifying recurring elements or processes, abstraction, focusing on essential details while ignoring irrelevant information, and evaluation, which involves assessing the efficiency and effectiveness of a solution. We integrate these skills into the course through various Scratch programming activities and project-based assessments. The study involves 2 groups of students, 10th and 11th grade. Participants were selected based on their interest in computer science, willingness to attend the elective course. The pre-test and post-test consisted of 2 main components. First, there were Scratch programming tasks designed to assess the students' ability to apply Scratch concepts to solve problems. This task increased in complexity through the course, evaluating the mastery of blocks, control structures, data handling, and event handling. Second, we included a computational thinking assessment. It measured the students' general computational thinking abilities, focusing on the skills I previously mentioned, such as algorithmic thinking and problem decomposition. The combination of evaluating the Scratch project and the computational thinking assessment gave us a comprehensive view of their development. Here on this slide, you can see the results of the participants' self-evaluated Scratch programming skills. As you can see, the initial self-evaluation of Scratch proficiency varied among students. This graph shows the difference in participants' proficiency levels from the beginning to the end of the course. It represents the increase in Scratch proficiency level for each participant, demonstrating the positive impact of the course on their skills. To give you a concrete example of the course assessment, this slide shows the project where students designed a simple game with multiple levels. These assignments were designed to reinforce the concepts taught in each module and encourage creative problem solving. In conclusion, the development and evaluation of our elective course on Scratch programming has shown promising results. The course is effective, improves student outcomes, and has high satisfaction among students. Scratch programming in Lyceum curricula fosters algorithmic thinking, creativity, and digital skills. Scratch is a powerful tool and provides a foundation for future success in computer science education. Our findings suggest that a structured Scratch course with project-based learning can be a valuable pedagogical tool. That's all. Thank you for your attention. I'm happy to answer any question. Thanks.
And we have a question. Alexandra, please.
Yeah, thank you. I have one question. Please say, can you provide more details about the project-based learning you used in your course?
Thank you for your questions. Project-based learning was central to our course. Each module included smaller exercises and activities that built towards a larger projects. Students worked individually or in small group to design and develop their own Scratch projects. These projects were designed to be open-ended, allowing students to express their creativity and apply the concept they learned. For example, in one project, students might have created an interactive story with multiple characters and scenes. This approach encourages active learning, problem solving, and collaboration, making the learning process more engaging and meaningful. Thank you for your question.
And I see that Vasil have a question. Please, Vasil. Please.
Thank you, and thank you, authors, for the sharing research results. Dear authors, your approach is interesting, particularly your choice of programming environment. But why did you choose Scratch for elective course in grades 10 and 11? Isn't it a visual programming language exactly for elementary school, for grades first, second, and so on?
Thank you for your question. I am grateful for your question. While it's true that Scratch is often introduced in elementary school, we choose if for several key reasons within the context of our Lyceum course. That accessibility and engagement, foundation for computational thinking, creative expression, adaptability. While Scratch is simple to begin with, it can also be used to create a relatively complex project. In summary, while Scratch is indeed used in elementary school, its strength lies in its ability to make programming accessible, engaging, and effective for teaching fundamental computational thinking skills, which are highly relevant and beneficial even for Lyceum students. Thank you for your question.
Thank you, Elena, for your answer. And we have 3 questions on the chat, but for economy time, Elena, try to write your answer for this question on the chat. And we go to the next report. Methodology of training future computer science teachers to implement game-based learning, a case study. And speaker Verbovetsky Dmytro, please.
Good afternoon, dear colleagues. I'm pleased to present you to our research on the topic methodology of training future computer science teachers to implement game-based learning, a case study. I am a fourth year postgraduate student, Dmytro Verbovetsky, magnificent supervisor, Vasil Petrovich Alexiuk, Doctor of Pedagogical Science, Professor, Senior Researcher. The modern education system is rapidly changing under the influence of digital technologies. Among them, AR, VR, and gaming technologies attract special attention, but it is digital gaming tools that have the advantage of accessibility, motivational impact, and ease of implementation. For future computer science teachers, this is not just a trend, but necessary component of professional training because they are the ones who must teach the generations that grew up in a digital environment. Therefore, the issue of formatting their readiness to use digital gaming tools is extremely relevant. The goal of our research is to develop a methodology for training future of computer science teachers in the use of digital gaming technologies. The objectives of our research are to analyze research in the field of gamification of game-based learning, describe a model for training future computer science teachers to use gaming technologies, and check the effectiveness of technique. In the process of developing the methodology, we were guided by the following principles: comprehensive, integration, the content, methods, and means; systemic, the interconnection of all components of training; competency, orientation on the development of professional competencies; personally oriented, taking into account the needs and motivation of students; and activity, learning through active practical activities. The slide presents a model for training future computer science teachers to use gaming technologies. It consists of 5 components: target, content, methodological, technological, diagnostic, and effective. The target component of the model describes the standards, needs, approach, and purpose for its use. The core of our model is the content methodological component, which contains the content of training methods and forms. The technological component of the model identifies services, resources, and software for using gaming technologies in the process of training future bachelors of computer science. The diagnostic component reflects methods for diagnosing the level of formation of professional competencies. In the model, the assignment of the formation of professional competencies is carried out according to the following 4 levels: initials, sufficient, average, and height, which correspond to the European credit transfer system, generally accepted in higher education. The result component contains as a result of student learning. Each component determines key aspects of the educational process, from goal formation and selection of means to evaluating results. These models become the basis of the development and implementation of an elective course. We have created a course in the Moodle learning management system called Methodology of Using Game Technologies. The model was implemented through the creation of a selective course, which includes 3 thematic blocks. First, gaming tools for creating quizzes. Second, gaming tools LMS module. Third, using Minecraft in the process of teaching computer science. And fourth, subfolder control. Let's consider one of the topics in more detail. This slide shows examples of practical tasks that students complete. Each topic consists of theoretical material and practical work, as can be seen in the pictures. For the topic of gaming tools for creating quizzes, Kahoot and Blockit are studied. And for each tool, the students has the opportunity to complete a practical task. Similarly, for other topics, of course. As a part of the first topic, students are introduced to popular digital platforms for creating quizzes, such as Kahoot and Blockit. These tools allowed you to develop interactive tasks that motivate students to actively participate in the educational process. The classes cover the possibilities of personalizing tasks, setting up game modes, using timers and a scoring system. Students take a teacher-prepared quiz in Kahoot to consolidate their knowledge. The practical part of the course involves students creating their own interactive quizzes on selected topics from the school computer science course. Special attention is paid for the analysis of how the game testing format can influence student motivation, the formation of a competitive spirit, and increasing interest in learning. Pedagogical strategies for using quizzes in the classroom are also discussed, both as a stage of mastering new material and during generalization of knowledge control. In the second topic, students are introduced in detail of the capabilities of the LMS Moodle for creating game-based educational elements. Since Moodle is a universal system for distance learning, it is important to be able to use its functionality as a repository of materials and as an active environment for interaction and motivation. Special attention is paid to the game modules, such as anagrams, crosswords, quizzes, and other tools that can be added by installing additional plugins. Students learn to integrate the elements into the course, configure difficulty levels, define a scoring system, and feedback. During practical work, participants develop their own game task for specific computer science topics into account the age characteristic and level of training students. Examples of creative use of Moodle for organization educational quests and missions are also considered. As part of laboratory work, application creates their own interactive task. In particular, they add a resource of the anagram type in which they form a set of the game. The point is to make the correct word or phrase from the jumbled letters. Within the third game, students work with Minecraft Education, a tool that allows them to implement educational tasks in a gamified format. The platform allows them to create virtual worlds in which students perform programming tasks, solve algorithmic puzzles, and develop logical thinking. Minecraft Education mode that is the most conventional for educational purpose in the course methodology of using game technologies, as it allows students to focus on creativity without resource limitation. One of the main tasks is to create their own game worlds, which contributes to the mastery of algorithmization and programming topics. The test effectiveness of the methodology, we conducted the pedagogical experiment. 53 fourth-year students participated. After completing the course, they filled out a questionnaire on a Likert scale. We choose the self-assignment method because we consider it inappropriate to compare these groups with others who did not have similar experience. This approach allowed us to use on assessing the students' own in knowledge and skills. We calculate the median at mode. The questions have generally confirmed their ability to perform these tasks. However, analyzing the answer of the first question, we concluded the most students can configure the blocked environment so that participants can play in real time, but a certain part of the respondents has difficulty. Analyzing the third question, we claim that among all respondents are significant confidence in their ability to create their own world in Minecraft Education, where players have unlimited access to all resources, cannot be harmed by the environment, and build any structures analyzing the other questions. we can say that students have a high level of development of skills in using command blocks to automate process in Minecraft education. This slide shows a frequency analysis of the responses. The nominal Likert scale was converted into a verbal one, where the score 1 is strongly disagree and 5 strongly agree. Most of the questionnaire questions were constructed according to the Likert scale. Its use justified by the need to measure the level of arrangement with statement regarding students' readiness to the digital game technologies for educational purposes. The slide presents the generalized result of the assignment of the effectiveness of the employment methodology. The obtained average values for all questions shows that the overall level of confidence of respondents in complementing the task is 5.01 points, which interpreted as high. The result showed that students highly rated their readiness to use the Kahoot and Blockit tools. The lowest score whereas in the Minecraft section, which is related to the complexity of the environment. The interquartile range analysis showed some functions in the levels of mastery of the tools, but the overall traits was positive. The course really interested the level of professional training. For a deeper analysis of the scale structure, it's advisable to examine the relationship between the responses to individual items and the overall score. Items that demonstrate a high correlation with the summary score can be considered as those that better responds the essence of the scale. In our study, a correlation analysis was conducted to assess the relationship between individual questions. Since the data do not fall under normal distribution according to the Shapiro-Wilk criterion, we use the non-parametric Spearman rank correlation coefficient R. This allows us to assess the strength and direction of the relationship between rank variables. On the slide, you can see statistically assignment correlation coefficient values with a p-value less than 0.05 crossed out. The values on the table diagonal are always 1 because each question correlation with itself. The table shows a high positive correlation between questions 7 and 8, R equal 0.714. This indicates the respondents who are confident in setting up command blocks in Minecraft education are usually equally confident in setting up a multiplayer in the environment. Given the relatively large number of these disagreement responses, we note that the coefficient also reflects the corresponding uncertainty of students. The moderate correlation coefficient for questions 6 and 8 R equal 0.526 indicates that the same students are equally confident and uncertain about the skills in Minecraft education. We also found moderate correlation coefficient value for questions 3 and 7 are equal 0.563. Instead, a similar relationship should exist between similar questions about students' pedagogical skills 3 and 6. Here we can assume that the first year students were not frank in answering one of these questions. Other coefficients reveal a weak relationship between the questions. All negative values of the correlation coefficient were statistically insignificant. Therefore, there are no means whose confidence in use has an inverse effect on the level of self-assignment of others. In conclusion, we can say that the developed course effectively forms students' readiness to use digital technologies in education. Such technologies not only diversify the educational process, but also contribute the development of professional competencies. We see further research in expanding the tools, including IA, VR, and studying the impact of game mechanics on student motivation. Thank you for your attention.
Thank you very much. Dear colleagues, please, your questions.
We have questions on the chat.
All right. I read aloud this question. How might the methodology described for training teachers in digital gaming technologies be adapted for different educational contexts or cultural settings, particularly in regions with limited technological researches compared to Ukraine?
If it's possible, I will answer for questions regarding this question. Our methodology is not specified to certain region or cultural settings. Regarding the second part of this question, students create their own teaching materials and game-based scenarios during training, which fostering the ability to tailor digital games to specify classroom conditions, including those with limited infrastructure and hardware resources.
Thank you. Next question. The study showed that students had more difficulty with Minecraft education compared to tools like Kahoot and Bluecat. What specific strategies could be implemented to address these challenges and improve teacher confidence with more complex gaming platforms?
Yes, thanks for interesting question. For our opinion, the main strategies and techniques for developing students' competences and as a result their confidences is use game technologies. In use game technologies are constructivism, project-based learning, and first of all, the broad use principles of game-based learning in teaching, starting from the first year of teaching students in universities.
Thank you. And the third question, given the correlation analysis showed interesting relationship between different skill assessments, how might future research expand to identify with specific pedagogical approaches are most effective for developing integrated gaming competencies in teacher education programs?
Okay, most of statistically significant Spearman coefficients obtained in our research values relate to use the Minecraft education platform. This platform has some, the using of this platform has some troubles of students regarding their confidence. They describe it in more detail in our paper. And another moderate relationship was also found between students' ability to design lessons using Kahoot and setting some parameters such as multiplayer mode in Minecraft education platform. We believe that this is the basic for in-depth training of students for the integrated use of these tools in particular in a course of methodology of teaching computer science or pedagogical practice in school. Thank you.
Thank you very much. We have a question from Sergei Alexeyevich Semeryakov, please.
Thank you, Andrei Mykolaievich. Thank you, Vasily Petrovich. I have, as usual, a provocative questions. No, first of all, today we have Moodle, Kahoot, etc. A lot of titles, but in 5 or 10 years, Moodle will die, Kahoot disappear, Minecraft for education will be, no, probably sky building for learning, etc. What survive? What survive from this research in a quite short 15-20 year period, which productive ideas we will use from this research in recent years?
Thank you, Sergei Alexeyevich, for probably interesting and insight question. As for me, this question not only about game technologies, but regarding digital technologies at all. I believe we must to form and develop skills and competence of students that not relate certain technology, but it about critical thinking, problem solving, analyzing data, and so on. It's broad and fundamental skills that I believe
that will survive despite of technologies, etc. My second question is about the theories which your research grounded. I'm sorry, I was in another not so useful but needful talks, but I think that you use not only clean constructive approach. I think you use constructionism in the papered traditions. No, you use really game-based. The papered things on this, in his Mindstorm books with Adel Goldberg, etc., is that only during game we can teach effectively, and the object of game is need to be a computer and another computer and related tools. I really interesting which theories except the constructivism and constructionism you use. Do you use social construction, or the related students are working alone with these tools and others? I really would like to think about your grounds, that solid grounds is a bright future.
Sergei Alexeyevich, we don't use another background such as social
social
aspect.
constructivism and social constructionism is as most related both Moodle and Minecraft and even Kahoot and other theories. Thank you so much, Vasil Petrovich. It's a really good ground which will survive in years and decades, despite the particular titles will be changes. Thank you so much.
Thank you for discussion.
Thank you very much. So we haven't another question, and thank you again. And I want to invite to finally presentation Alexandru Stetsishinu with presentation a specialized Ukrainian Polish computer science translator for primary education, design and implementation. Please, Alexandra.
Yeah, okay, now 1 minute.
Well.
Do you see my presentation?
Yes, I do.
Yeah, thank you. Okay, good afternoon, all of you. My name is Stetsishina Alexandra. I'm a master's student at the Kryvyi Rih State Pedagogical University. Currently, I would like to present a work entitled Specialized Ukrainian Polish Computer Science Translator for Primary Education Design and Implementation, written by Irina Minty, Alexandra Stetsishina, Olena Tarasova, Tatiana Vakaluk, Sergei Semerikov. This work lies at the intersection of informatics, pedagogy, linguistics, and international cooperation. It was motivated by a concentrated need to help children and educators overcome language barriers in understanding key informatic concepts, particularly between Ukraine and Poland. So let me begin to explain in the context. In Ukraine, informatics has become a mandatory subject starting from second grade, according to the state standard of primary education. This early introduction reflects a global trend. Children are learning digital skills from a younger age than ever before. At the same time, Ukraine is becoming more integrated into the European educational space. Its concepts more important with became a war in Ukraine. And many families move between Ukraine and Poland. There are joint Ukrainian-Polish schools, language immersion programs, and partnerships. So it is not uncommon for students to be exposed to educational content in both languages. But here lies a challenge. Informatics technology is not always consistent, clear, or age appropriate when within one language, let alone across two. Children may hear a term like permykacz in Ukrainian, but encounter a different word or structure in the Polish, such as przelążnik. Worse, some textbooks use terms and are overly technical or vague. So how can we help young learners understand core informatics concepts without being confused by inconsistent vocabulary? This brings me to problem and is addressed in this project. Today, there are no specialized tools designed specifically to translate informatics terms between Ukrainian and Polish, and especially not for children in primary school. Yes, Google Translate exists, but the general bilingual dictionaries. But these tools do not offer contextualized or grade appropriate translation. reflect the specific terminology used in national curricula, or consider how children actually learn and use digital terms. As a result, students may learn an incorrect term or misunderstand a concept entirely. Teachers who use materials from both countries may also struggle to explain this consistently. That's why I decided to create a dedicated online translator focused only on key informatics terms for primary education with clear and child-friendly requirements. Before any code was written, I needed a reliable terminological foundation. I started by conducting an in-depth analysis of the two main Ukrainian educational programs, Savchenko and Shean. A range of 4-grade informatics textbooks officially approved by the Ministry of Education, and Polish national standards for early informatics and media education. So this project I complete at least about 100 core informatic terms such as information, informatia, data, den, and something of this. I compared these terms in defined overlaps and result differences in meaning of the usage. For example, while message in Ukrainian often translated as a powiadomienie, in Polish it may appear as komunikat or wiadomość, depending on context. All terms selected were frequent, essential for classroom use, and adapted to the cognitive level of children aged 6 to 10. Once the dictionary was ready, I began working on the translated interface. I chose to implement it as simple browser-based web tool using the 3 key technologies: HTML from basic structure, CSS from the colorful and accessible design, and JavaScript to add interactivity and real-time translation feature. The user experience is straightforward. A student or teacher can type in a term in either language, the translated text and language, and displays the correct equivalent. It works directionally from Ukrainian to Polish and from Polish to Ukrainian. And the interface is minimalist with large input fields, bold fonts, and not distraction. It was designed with accessibility and young learners in mind. Here you can see the tool looks like in the practice. The page features a main input field, a drop-down to switch the select language direction, and a result box, and instantly display the translation. In addition, I've added a small set and helpful hints that explain tricky terms in a simple language. And so how can this translated be used in real classrooms? There are several key applications: bilingual education. These schools or classes that include Polish-speaking students or use Polish materials alongside Ukrainian ones can be benefit directly. Teacher training. When Ukrainian teacher participant on Erasmus Plus or Polish collaboration projects can use it to understanding curriculum terms. It's homework and self-study. When children working on informatic tasks at home may encounter foreign terms online, this tool helps them clarify meaning instantly and consistently in terminology. When even within one language, the tools reinforces the use of standardized terms from the official curricula. Naturally, there are challenges in this process. One of the biggest was the lack of the one of the matches between terms. Some concepts exist one of country's curriculum, but not the other. Other have multiply meanings depending on the software used or the context of instruction. For example, executor or performer can refer to a child, a robot, or sprite in Scratch. And I have to make sure that translators reflect how them in use their classroom and not just in theory. To solve this, I added contextual notes for certain to the most relevant synonym and consulted with teacher to ensure terms were understandable and accurate. And I see this project as a starting point, not a finished product. In future, I plan to add voice pronunciation to help students learn the correct way to say terms, include simple illustration or icons for visual support, expand the glossary to cover more advanced terms as students progress grades from 5th to 6th grade. Possibly develop a mobile app version that works fully offline, and eventually include other languages such as English or German for use in multiplying schools. And to summarize, this translation was created to address a very specific but very real need, helping young students young children and their teacher understanding informatic terms clearly, even across languages. It promises consistency, supports inclusive education, and strengthens digital literacy from their earliest levels. As our world becomes more connected, language should be never a barrier and understand fundamental digital skills. I hope this tool contributes even in a small way, to building a better, more integrated digital classroom. Thank you very much for your attention.
Thank you very much. Dear colleagues, please, your questions. Well, Vasil Petrovich, please.
First of all, thank for your interesting research. Its practical result are beyond doubt. But my question is about what is your motivation for creating an online translator in context of using online translator based on AI?
Sergey Alexeyevich, please.
As co-author, I would like to dive in this research. It was a bachelor thesis guided by Irina Sergeyevna, and really a year ago the first idea of Alexandra Yurievna was to make a machine learning model that supports such translation, but the main motivation don't use general models or well-established translation tools was a terminology. According to research conducted by Alexandra Yurievna, we found a wild zoo regarding the Polish-Ukrainian terminology. Moreover, most of inconsistencies between Ukrainian textbooks and Ukrainian model program. For example, well-known textbooks don't cover in the best way from quarter to half of the needful terminology. So, in case when we use well-established translation tools, we produce translation that was not related both the term used in textbooks and term indicated in the program. It will be quite good computer science term, but not in the early grade education. So it's rather in the current stage of research is not rather translation. It rather a strict terminological dictionary, really strict, both for two languages. So the productive idea to use AI tools was rejected by this paper co-authors and by me in person. Thank you, Vasil Petrovich. Any other questions? We big collective that fruitful work in this field.
May I also ask a question? So nice to see you, dear Sergey Alexeyevich. So thank you for interesting presentation. I have maybe even two questions. First one, if there are any possibility to upgrade this let's say vocabulary, and who is going to do it? Is it possible to? Is it an administrator of this application, or how it's going to be? And another one, it's about maybe the prospects of development of this dictionary. Are you going to integrate there maybe the functionality of simulation, not only to translate it, but also to work out for a possibility for a school child to work out this vocabulary and to learn it, not only to translate, but also to get it as your own let's say heritage. Let's say it in such a word. So maybe rather about prospects. No.
Dear Людмила Eduardovna, thank you for your fruitful proposal. No, we really don't plan to use a kind of simulation, but it's a very good idea. Regarding the current technical stage and who can administer this vocabulary, I would like to this question will be asked by Alexandra Yurievna.
Okay.
Yeah, I will say this. The modified vocabulary can just only author who published this project on web server. And unfortunately, now we have only one way to modify this vocabulary. It's make more more bigger vocabulary and make other dictionary. And maybe in future we make function who help us to do it online. And we don't need to modify all dictionary, just some parts. And I agree, this translator need UI UX design more more helpful, maybe with icons, and to use the, some pictures to help more understanding and more learning new words to children. And I think in future maybe can make something like play or based on this theme when pupils will learn new words, and after that play a game to
in order to work it out and to remember it better, to
yeah
simplify mastering. Yeah, and also
and
I'd recommend you also to pay attention as for so-called accessibility, not inclusive. Nowadays it is used rather accessibility. So your interface must be how to say good for universal audience, for people with all kind of abilities, disabilities, diversity, and so on. It would be also for better, for your beneficial, for promoting of your product. Okay, thank you.
yeah, thank you so much.
Thank you very much, Alexandra Yurievna, Lyudmila Dorna. I would like to make a small addition. Due to open source nature of these projects and it hosted on GitHub pages, everyone can clone the related repository and make any needful changes, both in vocabulary interface on your own.
I see. No, maybe it's maybe not really good on the one hand, but on the other hand, maybe it gives more accessibility.
At least a vocabulary core in a very simple JSON format that can be exported and used as a core of new projects.
Okay, thank you. I wish you best wishes as for promoting and so developing your project. Thank you.
Thank you so much.
Thank you, Alexandra, and all co-authors. Please question your colleagues. No questions. Well, dear colleagues, we have exhausted today's conference program. I want to thank everyone for their active participation, and interesting presentations. And I would like to ask you to turn on your cameras and take a collective screenshot, please. Well, I take screenshots. Thank you very much. Thank you. And maybe who's want talk some words finally.
Maybe Serhiy Semerikov.
Please.
This is not the end of our conference. Tomorrow at 1 p.m. We will have an excellent educational technology session. So I would like to invite all, both participants and all our stakeholders to join this section tomorrow. Thank you.
Thank you very much. Thank you to all
the participants and all the organizers. It's very nice to get together again every year, and it's really interesting and nice experience of communication. And good luck. Stay safe, everybody. Bye bye. Thank you.
Thank you. See you tomorrow, I hope.
See
Bye.
you. Bye.